Hello, I'm Piero. I'm a software engineer at Vechain, and today we'll be looking at how to build a Vechain application particularly fine-tuned for the VeBetterDAO. The VeBetterDAO is a community. It's a community in place to make the world a better place. Behind the scenes, it's a decentralized autonomous organization with a lot of unique features in our industry. In particular, through many applications, the VeBetterDAO is able to reward users that perform sustainable actions through the Better token. And if you want to join this ecosystem as a developer, as a builder with one of your applications, this video is for you. Let's see a couple of examples already existing inside this ecosystem. We have X to earn, which is the concept of doing something to be rewarded. So X can be anything. To earn means that you're getting rewarded with the Better token. For example, mugshot. The X factor in mugshot is that users choose reusable mugs when drinking their coffee, therefore not choosing disposable cups that are a big factor, in particular with cafes, coffee chains around the world. And you get rewarded with a fun and simple experience through the Mugshot app for choosing a reusable mug, drinking your coffee, thanks to cutting-edge AI technology, all built on the Vechain blockchain. You have also Cleanify. That's also an innovative application on Vechain, which rewards users that clean their streets, remove the rubbish, clean the beaches, through also, in this case, cutting-edge AI technology, manual verification, and also this application is built on Vechain. And as you can see, these are only a couple of examples inside an ecosystem that is growing rapidly. You have Mugshot, Cleanify, Green Card, Green Ambassador Challenge, Oily, EVEarn. With EVEarn, you get rewarded by charging your Tesla, for example, or your electric vehicle in general. So a lot of applications are joining, and this is your chance to join a rapidly growing ecosystem with a lot of important values, such as the fact that it is also a decentralized venture capitalist for your application. In fact, through the decentralized governance system, users are able to vote their favorite applications, which then in return receive better allocations in the Better token to then reward their users for their sustainable actions. Now let's jump straight into the juicy part of this video, building our X2Earn application. So first things first, head to the description, and there you'll find a link to the template from which we'll be showcasing and walking through every important detail to be able to build your very own X2Earn application on the VeBetterDAO. As of any new repository, the first thing we look at is the README. And inside the README, you are quickly greeted with what is required to run this project. First of all, you need Node.js. So you need a Node version 18 or above. You need a package manager, for example, NPM, Yarn. You need to have Docker if you want to run a local Vechain node, which is what we'll be doing in this tutorial, in this walkthrough. And you also need Hardhat to be able to run the smart contract suite from compiling, testing, and also deploying to all the Vechain networks. The project structure you'll be greeted with inside the repository is both a frontend and a backend, but also the smart contract suite, together with some reusable packages between all the applications. In fact, let's just dive quickly into the repository first to be able to see exactly what the repository contains. This codebase is a mono repository built using the Turbo framework. Turbo allows to manage mono repositories in a more facilitated, optimized way. In fact, everything is already set up for you to be able to run front-end and back-end with one single script, and also call the smart contracts compilation and deployment, or also testing with also a few amount of command lines. First of all, let's have a look at the applications. So you have, as we said, a backend, which is there to be able to perform a series of tasks we'll see very shortly. A contracts application, which has the smart contracts that we need and also scripts for deployment and testing. Then we have the front end too, which will be demoed also very shortly. In fact, before we go into more details, let me just show you exactly what this template is, so you have a better understanding of what an X2Earn app should do and should look like. So let's head over to our browser, and here is the demo front end. What's happening here is that we are showing the user exactly what he needs to do. So purchase eco-friendly products. Then he needs to upload the receipt through the drop down below. And if the receipt passes the verifications required, then he is rewarded with the Better token. In this case, just for demo purposes, the verification checks simply if the receipt is a physical receipt with at least one product, sustainable product purchased. Otherwise, the AI sends the analysis through the backend system back to the user as of why the submission was not validated. First of all, let's try with this digital receipt that should not pass. Okay, so it's saying please connect to your wallet. So first of all, let's connect our wallet using vWorld. If you have not got vWorld installed, make sure to head over to the Chrome web store and install vWorld in your browser, in your Chromium-based browser. Then back to the application, we head over and sign in. So basically connect our wallet to the front end. And now let's try again sending the receipt. So now we're sending the receipt to our backend service, which is running. And I'll show you exactly how to reach this point, having the backend running, the smart contracts deployed, and everything necessary to be able to reach this step. And the AI says that the image is not a receipt of a product purchase, but an invoice for clothing items. Now let's try again with another receipt, for example, this one. And this time it should pass. Let's see. There you go. So you've earned one Better token. And to verify the balance, we can even head to our wallet again. Go back to networks, solo network, which is the local network I'm utilizing, which I'll show you exactly how to set up shortly. And here we can see that I have a lot of tokens because with this account I also deployed the mock token of Better. But at the end you can see that there is one more token, which is the one that we just received. Now let's head back to our code base and deploy our smart contracts. So if you head to the apps contracts route, you'll be presented with the typical hard hat smart contracts suite. And inside the contracts directory, you'll have the EcoEarn smart contract, which is the core smart contract of our application. Interfaces needed for ERC20s, for example, and also mock contracts that both mock the Better token of the VeBetterDAO and also the smart contract that handles rewarding of the users, which is another smart contract part of the VeBetterDAO. Now let's briefly look at the EcoEarn smart contract. This is a very simple smart contract, and I invite everyone to read the smart contract in detail and understand it fully before proceeding in modifying it or writing a completely new version. Now, if you already have your smart contract suite ready, that's amazing. But if you want to use this template as a starting point, then make sure you completely understand what's happening. The core concepts of this smart contract are the fact that it's a round-based rewarding system. Every round has a specific cycle duration, and each cycle there are a maximum number of submissions a user can do for that round. How does the rewarding happen? The rewarding happens through the register valid submission function. This function is called by an admin, which in this case is the backend. The admin specifies the participant, so the address of who we are going to reward, and the amount in way that we're going to reward in terms of the better token. It does a series of checks. For example, the amount is greater than 0. The participant has not exceeded his maximum submissions. There are enough rewards left, and then obviously that the cycle has not ended. What happens is that the submission counter for the participant increases by 1. The total submissions increase by 1. The rewards left for this round decrease by the amount we're rewarding, and then the reward distribution happens. The last field of this method that is called needs to be populated by the sustainability proof. You can read all about sustainability proofs in this link, but to summarize all of this, applications are required to provide a proof of the sustainable action the user performed, thus the reason why he was rewarded. This can be a JSON uploaded to IPFS, for example, or even to your own centralized solutions, showcasing the exact format that can be detailed in this document. But now let's look at how we can deploy the smart contracts. So if you head back to the root of the project, you are greeted with yarn contracts deploy solo, because we'll be deploying on the solo network. And if you haven't got the solo node running locally, which is a Vechain node mock instance that can be run locally for testing, all you have to do is head over to the contracts package, call yarn solo up, which is another script, which then instantiates the Docker container having your Vechain solo node running locally. Obviously, you need your Docker daemon active and running. Now, let's go back to the root and call yarn contracts deploy solo. What this script does is deploy all the necessary contracts that can be found in the scripts deploy file. So first of all, we are deploying the mock token because we are on the solo network, the mock token of better. So we'll have the better token on our local solo node. Then we are deploying the mock contracts needed for rewarding the user. And at the end, we are also deploying the eco-earn smart contract. There you go. Once everything is done, you will have the addresses of the deployed contracts in the console, but also under the config file of the packages config contract package. You'll also have the token address and the contract address automatically refactored, putting in the correct deployed addresses for you. Now, to correctly verify that the deployer has the tokens that were minted to him upon deployment, we can verify this, for example, in the vWorld wallet. In fact, a quick look at the better mock, we can see that the deployer, of the better mock is minted with 10 million better tokens. In fact, let's quickly copy the token address, which is here. Head over to our browser, to the Vechain wallet again. If we go to add custom token, paste the address of the token, then we can see the better token has been added, and now in the home screen you can see that there are 9,998,000 better tokens. This is because 2,000 better tokens were used to fund our application. In fact, back in the in the deploy script, you can see at the end that the reward token was deposited to be able to reward our users, in particular 2,000 better tokens. Now, before we go back to the next steps inside our README, I'd love to invite everyone to be aware that we are currently pointing to the solo network inside our wallet. This might not be the case for everyone. In fact, when you add the token before, if you do not see any balances or if you do not see the token, most probably this is because the solo network needs to be added to the wallet. In fact, head over to Settings, Networks, Add Custom Node. Here you can write solo or solo local and make sure that the URL is http://localhost column 8669. This is the endpoint from which the Vechain solo node that you're running locally is exposing the REST API. In fact, a quick search on this should redirect to the REST API of a Vechain solo node. Now back to our template. What you see here are steps to reward our user, but before rewarding the user, we are funding the X to earn rewards pool with better tokens to be able to reward that user. Now, as you can see inside the script, already 2,000 tokens have been deposited, so we can skip this step. But remember that to add more tokens, you will need to have the contracts instantiated inside your inspector. To do so, all you have to do is copy this command here, npx darren devpal, etc. Go to your command line interface, paste it, and you'll have an instance of the inspector running locally. Here I already have the contracts instantiated previously, but all you have to do is click the plus icon, put the name of the contract, the address, and the ABI of the contract. To find the correct ABI of the contract, all you have to do is go into the apps contracts application in your codebase, artifacts, contracts, and here you will have all the ABIs of your contracts. For example, the ABI of the X2Earn rewards pool mock is inside this folder, and then you have to go to the JSON and copy this entire array under the API key of this JSON file. All you have to do is then paste the ABI array here. We've already done that. The only thing that's left on our side is to start the round. So I'll be walking through exactly the starting process, which can be found also at this step here. So first of all, we need to specify the correct contract address. So I already have the EcoEarn contract here, so let's edit it. The address, let's see if it's the same. It ends by C7BF, so let's copy this, paste it here. The ABI remains the same as I put it before. Now, if we do a quick check on the current cycle, it should be cycle 0, exactly, because we have not yet started any round. So the first round will be the cycle 1. Now, what we can do is set the rewards amount for the next cycle here to 1,000. But 1,000 is not the correct value because what Solidity expects is the value in Way. So if you head over to eth-converter.com, you can then convert Ether value, which is the same as VET value or better value, into the Way value, whereby the Way value is the 18 decimal representation of the amount. We can then copy this value, which is 1,000 in the better value, head back to the EcoEarn set rewards amount function, specify the amount here, call execute. This will then prompt our wallet with the correct function, as you can see, set rewards amount. Now let's sign the transaction, send the transaction, and what we can now do is verify that the rewards left for cycle 1, which is the next round, is 1,000, and there you go. So this is 1,000 in Way. Now that all that's left to do is trigger the cycle. So let's trigger that. Sign. And now let's check again what the current cycle is. And there you go, boom, we're at cycle 1. So the first round has officially started. Now we should all be good to run our front end and back end. Head over back to the codebase. In the root directory, we can do a simple yarn dev. This, through Turbo, will be able to spin up both the front end and the back end that are pointing to our freshly deployed smart contracts. So as you can see in parallel, both the front end through the Vite framework and the back end through an Express Node.js framework are running. So we can now head over to localhost 8082, whereby our front end is running. There you go. And let's try and add our receipt again. As you can see, the request has been correctly sent and the backend has already replied. In fact, AI says that it's not working. Now let's look exactly at what is happening behind the scenes on our backend. To do so, I'll be using another IDE called IntelliJ to be able to debug. You can also do that with Visual Studio Code, but I prefer IntelliJ for debugging backends in general. So let's head over to our root. We can cancel the process running with Ctrl+C. Now let's only run our front end. So cd apps frontend yarn dev again. And if we go to IntelliJ, we can now head over to the package.json of the backend. There you go. And here we have yarn dev. Let's run yarn dev in debug mode. Inside the backend, you have a controller called the submission controller. Here you can see the controller as your first visit for the requests coming from the front end. In particular, you have submit receipt, which is the controller of the business logic in terms of where to send the flow of validation. In fact, let's see exactly what's happening behind the scenes. Again, let me send a receipt. And here we go. So in debug mode of IntelliJ, we can go step by step into what's happening with our submission from the front end. So the front end, as you can see, is sending in the REST post HTTP body the address, a captcha token, a device ID, and the image, which is encoded in base64. All of this is formatted through the front end and business logic that is already implemented in the front end. Once that is parsed, we then check if the captcha is valid. Captcha validation is very important because it allows us to limit the ways bad actors are able to contact directly our backend, kind of forcing them to go through the front end. This is very important in applications whereby, for example, you are forcing the user to use the front end taking a photo and not updating a invalid photo or faked receipt in this case. So for our example, whereby we are uploading it through our file system, this is just for demo purposes. But in a real world environment, for example, the application that rewards you for drinking coffee with reusable mugs called Mugshot, it forces the user to use the mobile application whereby users have to take an actual photo in real time. Now the submission request here is then parsed again, and we go and validate the submission. In this case, we're checking if the user has reached the maximum submissions. So it calls is user max submissions reached function, and then the return value is false, so the user has not reached his maximum submissions. And now we call validate image. Validate image is a helper utility function inside the OpenAI service you can find in the backend, and the prompt is very simple. It asks OpenAI in particular to check if the receipt has the element of purchase of at least one product. It is not a screenshot and it must include the date of purchase. It must also include the store where the purchase was made. These are very simple prompts and should not be used in a real world environment if you want to go live, but it's just for demo purposes. Also, every configuration environment variable is specified both in the environment variable examples and also in the README of the repository. Now back to the controller, what we can see here is that the validity factor is 0, And that's exactly what we asked OpenAI to send us, a validity factor of the submission. If the validity factor was 1, then we would go and register the submission by calling that famous method that we stated before, initially when talking about e-current smart contract, the register valid submission, whereby we specify the submission address, who is the participant, and also the amount to reward. In this case, we are passing the reward amount, fetching it from the environment variables, that is one better, into hexadecimal representation. Now, let's continue, and the backend sent to the front end the request with the analysis from AI. Last but not least, let's have a quick look at our front end. This is very, very simple. It's a React application built using the Vite framework. It has a couple of utility methods, such as the device ID I mentioned previously, and the compression plus conversion of an image to the base 64 encoding format, and a series of also utilities such as networking for submitting the receipt, some hooks around persistence, state management, submission management, and also some front-end components that are reusable. Remember, the front end is the key visit for any user. So let's try our best to keep it simple, but at the same time, sorry, we have some motorcycle enthusiasts in the background. I was saying, let's try and keep it simple, easy to understand from the user, but also make it as seamless as possible. Our intent is to diminish as many interactions possible to be able to submit their sustainable action. Otherwise, it becomes frustrating because not always even the submission itself is able to be validated. So keeping it simple for the user is key to this kind of application. Now, one thing you can notice in this type of application is that there are no transactions being signed on the application front end itself. If your application is and requires transactions to be signed on the front end, all you have to do is head back to the VeBetterDAO docs, so docs.VeBetterDAO.org, and see the integration example number 1. In this case, you have the use-only smart contracts, so the front end will also require the user to sign the transaction. If you need an example also for a template starting point that is a lot simpler than the one that we just went through, you can again go to your terminal and look for yarn or npm. So let's go with npm create Vechain-DApp. This then prompts you with a wizard that allows you to clone the XApp template we've seen, or also a React DApp template, a lot simpler in terms of code-based terms, with a front end and some smart contracts, with also the possibility to make transactions from the front end itself using vWorld. The app template we went through instead performs the transactions for the user on the backend service. Now, that's everything you need to know about the external app template. Obviously, there's a lot more inside the code base, but I'm sure you really have fun looking at it and building maybe the future of finance and sustainability, who knows. Again, if you need any help on our side, feel free to join our community. Below VeBetterDAO.org, you can find all the links that allow you to join our community and even our dev channels, including Discord and Telegram. So developers, fellow developers, please have fun building this, which is the most important thing. And let's hope we'll see you one day inside the VeBetterDAO marketplace itself. Thank you.